Vibe coding, tech stack. In this video, we're going to explain the technology stack of a Gen AI prototype. We'll be breaking down all the specific tools, the architecture, and the infrastructure that takes a project like this from a concept all the way to a full deployment.
So here's our roadmap. We'll start with a bird's eye view of the entire tech stack. Then we'll zoom in on the development tools, followed by the core architecture for data and logic. After that, we'll cover the deployment infrastructure, and finally, we'll tie it all together and talk about why this particular setup is so optimal for a methodology called vibe coding.
Okay, first up, the tech stack at a glance. Let's look at the layers, the development tools, and the hosting environment.
Now this diagram you see here, this is our blueprint for the entire discussion. It's really organized into three core pillars. On the left, you've got the functional layers, everything from the dev environment up to the Gen AI model itself. The middle column, Entwicklung, that's our list of the actual technologies used for development. And then over on the right, hosting, shows us where each part of the stack actually lives. So let's break this down piece by piece.
Let's start right in that middle column with the development tools. This is the developer's toolkit, the actual instruments used to write the code and build the application.
The foundation for the whole development process is an IDE called Cursor. You can think of it as being built on top of VS Code, but it's been redesigned from the ground up to be AI first, meaning AI assistance is woven directly into the coding workflow.
So, why Cursor? What's the big deal? Well, the critical feature is its deep contextual understanding of the entire codebase. It's not just looking at one file. This means it can help with really heavy lifts, like refactoring complex logic or debugging issues that span across multiple files at once. When speed is everything, that is a huge accelerator.
The programming language of choice here is Python. And that's probably not a surprise to anyone, but its role is absolutely central to the whole project. Python's dominance here comes down to two main things. First, it's just the default language in the AI world, so you get this incredibly rich ecosystem of libraries. Second, its clean, simple syntax is absolutely essential for the kind of rapid prototyping that is at the heart of vibe coding.
All right, next up is the user interface. For that, this stack uses Streamlit. And honestly, this is a real game changer for anyone who needs to build a front end quickly without being a front-end expert.
The advantage is really simple. You build your entire user interface without ever leaving Python. You get to skip a separate front-end framework like React or Vue entirely. This means you can create interactive dashboards and GUIs with incredible speed, allowing for a really fast, iterative development process right from your data scripts. Okay, let's move on to our second major pillar, the core architecture. Here, we're focusing on how the data and the application's logic are actually managed.
For the database layer, the choice is MongoDB. It's a NoSQL database, which means it moves away from those rigid, table-based structures of a traditional SQL system and offers a lot more flexibility.
So why go schemaless? Well, in AI projects, the shape of your data can, and often does, change constantly. MongoDB's flexibility is perfect for that. You don't have to define a rigid schema right at the start. On top of that, its cloud service, MongoDB Atlas, makes it incredibly simple to integrate with all the major cloud providers. Now, it's really important to understand how this project evolves. In the initial prototype phase, for the sake of speed, all the database and LLM calls are made directly from the Streamlit frontend. But for the final architecture, the plan is to introduce a dedicated backend. This separates all the logic from the presentation layer, which is a much more robust and scalable approach for production system.
And that dedicated backend, that's going to be built with Fast API. It's a modern Python framework that's exceptionally good for building APIs for AI applications. It's performant, and it has this great feature where it automatically generates API documentation right out of the box.
So we've covered the development tools and the architecture. Now let's look at the deployment infrastructure. In other words, how this project actually goes from a local machine out into the cloud.
This table gives us a really clear breakdown of the hosting environment. The code itself is versioned on GitHub. The Streamlit app is deployed on Google Cloud Run, which gives you scalable, serverless execution. The data is managed in MongoDB Atlas, and the generative AI model is accessed through the OpenAI API. You see how each component has its own distinct, dedicated service? It's a perfect illustration of a clean separation of concerns.
Okay, let's bring this all home. Let's talk about the synthesis of all these parts and why this specific combination of technologies makes for an optimal vibe coding stack. You know, the key insight here is that every single choice serves a purpose. AI integration starts right at the IDE level with Cursor. Development speed is clearly the top priority, with Python and Streamlit leading the charge. You have flexibility and scalability baked in with components like MongoDB. And the deployment strategy keeps everything neat and tidy with a clear separation of concerns. The whole thing is engineered for agility and intelligence from top to bottom.
This really leaves us with one final big question to think about. When your development environment is basically an AI collaborator, and your entire technology stack is optimized for this kind of rapid AI-powered creation, how does that fundamentally change the traditional role of the developer? What does our job even look like anymore?